NASA has released photos revealing an extraordinary phenomenon involving a star named Betelgeuse, which underwent an unprecedented outburst, ejecting a massive portion of its surface material. This event, termed a surface mass ejection, SME, expelled a mass 400 times greater than a typical solar flare from our Sun. The discovery has astounded scientists, challenging much of what we understand about stellar behavior. The extraordinary star, Betelgeuse. Betelgeuse, a colossal red supergiant, is located in the upper right shoulder of the Orion constellation. Known for its deep reddish hue, this magnificent star has long fascinated both astronomers and stargazers. Its pulsating nature, with a rhythmic 400-day cycle, further adds to its allure. Betelgeuse is one of the largest stars observable from Earth and has served as a focal point for countless celestial studies. Although commonly referred to as Alpha Orionis due to its prominence in the Orion constellation, Betelgeuse is outshone by Rigel, another star in the same constellation. However, Betelgeuse's massive size and reddish glow make it a standout celestial object. It is the 7th brightest star visible from much of North America and Europe, and the 10th brightest overall in the night sky. Cosmic giant. Betelgeuse's dimensions are staggering. It is 16.5 times more massive than our Sun and radiates 126,000 times more luminosity. If placed at the center of our solar system, Betelgeuse would extend beyond the asteroid belt, possibly enveloping Jupiter's orbit. Despite its immense size, Betelgeuse's surface temperature is relatively cool at about 3,600 Kelvin, making it less hot than the Sun. This star is surrounded by a cloud of material ejected unevenly, forming a nebula about 30 astronomical units in size, approximately the distance from the Sun to Neptune. This gaseous cloud is a byproduct of Betelgeuse losing mass at a significant rate, shedding about 1 solar mass every year. The surface mass ejection SME. Unlike typical solar phenomena such as coronal mass ejections, CMEs, which involve smaller portions of plasma and magnetic fields being ejected into space, Betelgeuse's surface mass ejection was unprecedented. The star launched a substantial chunk of its outer layer into space, resulting in an immense cloud of dust that dimmed its brightness as observed from Earth in 2019. This dramatic event caused Betelgeuse to appear as though it were wobbling like a bowl of jelly, according to scientists. The SME expelled material at an astonishing scale, 400 times more mass than a standard solar CME. This outburst disrupted Betelgeuse's photosphere, the visible surface of the star, creating a new and mysterious state for this red supergiant. The implications of Betelgeuse's behavior. This phenomenon has provided astronomers with a rare opportunity to study the end-of-life stages of massive stars. Betelgeuse is nearing the end of its lifespan, and such events could offer valuable insights into the processes leading up to a supernova. Stars like Betelgeuse derive energy from nuclear fusion, which gradually depletes their hydrogen fuel. As this occurs, heavier elements like helium and carbon are fused in the core. Eventually, the fusion of heavier elements like iron absorbs energy rather than releasing it, leading to the star's collapse and an inevitable supernova explosion. Betelgeuse, estimated to be around 10 million years old, is in its final stages of life. While it could go supernova within a few 100,000 years, its recent behavior hints that this dramatic end might occur sooner than previously anticipated. Observing a stellar evolution. Betelgeuse's pulsating cycles, during which its outer layers expand and contract, have become a key focus for astronomers. These cycles, which occur roughly every 5 to 6 years and last about 100 days, influence the star's brightness and temperature. By studying these changes, scientists aim to gain a deeper understanding of how red supergiants shed mass in their twilight years. The SME has also shed light on the processes behind Betelgeuse's dramatic dimming in 2019, which was caused by the expelled material forming a dust cloud that temporarily obscured its light. Such events challenge our models of stellar behavior, indicating that stars can undergo massive, unpredictable outbursts. A window into the universe's mysteries. Betelgeuse continues to captivate scientists and stargazers alike. Its unpredictable behavior offers a glimpse into the dynamic and often violent life cycles of stars. By studying Betelgeuse, researchers hope to unlock the secrets of stellar evolution, shedding light on the eventual fate of massive stars and the broader workings of our universe. As we watch Betelgeuse, a fiery red giant nearing its cosmic finale, we are reminded of the immense power and beauty of the universe. The story of this extraordinary star serves as a testament to the mysteries that lie beyond our own solar system, waiting to be uncovered. Astronomer Dupree has pointed out that until recently, we had never observed a massive ejection from the outer layers of a star like this. There is still much we don't fully understand about the phenomenon, leaving us to speculate. This is an entirely new event, and thanks to Hubble, we can now clearly see and resolve surface details. We are observing this stellar progression in real time, yet it's unclear if this development signals Betelgeuse's approach to a supernova, as the outcomes have been astonishingly unexpected. NASA cautions that Betelgeuse might not be nearing the end of its life yet. Even though it's a massive star, its timeline is vast, and red supergiants, while short-lived relative to other stars, still take time to reach their demise. According to NASA, Betelgeuse will likely explode within the next 100,000 years. Betelgeuse has been a subject of fascination since antiquity, with records of its observation dating back to the 1st century BCE. Recently, astrophysicist Serafina Nance and her team sought to predict the timing and impacts of a potential supernova, focusing on red supergiants like Betelgeuse to understand how such massive stars behave over time. Nance's team ran simulations using Betelgeuse as a model and compared their findings to field observations. A major mystery arose when Betelgeuse dimmed unexpectedly in late 2019, contrary to its usual cycles. Despite predictions of a supernova being far off, the star's brightness dropped dramatically. Betelgeuse, a member of the Orion OB1 Association, has been observed speeding through the interstellar medium at 30 km per second, creating a bow shock over 4 light-years wide. By mid-February 2020, its brightness had diminished to about 1/3 of its usual magnitude. After a consistent dimming since October 2019, the star began brightening again in February 2020. Scientists observed no significant changes in infrared data, suggesting that the dimming wasn't caused by internal core collapse but rather by other factors. One hypothesis is that a massive circumstellar dust cloud caused the dimming. In a 2020 study, astronomers suggested that large-grain circumstellar dust absorption could explain the event. Other research pointed to giant star spots or cooling on the star's surface as possible causes. By mid-2020, the star had brightened significantly again. Observations using the Hubble Space Telescope revealed that a surface mass ejection might have occurred, where material from the star's surface was ejected thousands of kilometers into space, cooling and forming a dust cloud that blocked light from the star. This dramatic event resulted in a visible dimming, even noticeable to amateur astronomers. The star's photosphere was disrupted but began to recover over time. The usual 400-day pulsation cycle of Betelgeuse disappeared, marking a significant anomaly in its behavior. Despite this recovery, Betelgeuse is now vibrating, much like a bell struck by a massive force. This surface mass ejection is a phenomenon astronomers have never witnessed before, highlighting gaps in our understanding of stellar physics. Scientists are closely monitoring Betelgeuse, hoping to learn more about the processes that lead up to a supernova. While a supernova is unlikely to occur in our lifetimes, no one can predict with certainty when it will happen. It could be tomorrow or a million years from now. If Betelgeuse does go supernova, Earth will remain safe. Astronomers estimate that a supernova would need to occur within 50 light-years to pose any risk to life on Earth, and Betelgeuse is over 650 light-years away. Instead of danger, the world will witness a spectacular display, as the exploding star would shine brilliantly in the night sky. This proximity allows astronomers a unique opportunity to study the supernova's effects in detail. Currently, Betelgeuse isn't visible in the night sky. Even if it had already exploded, we wouldn't see it until the light from the event reaches Earth. For now, scientists remain excited about the prospect of observing such a monumental event when it happens. NASA's James Webb Space Telescope might track the expelled material from Betelgeuse's surface as it moves through space, while Hubble continues to study the star. Stay tuned for more updates on Betelgeuse and other fascinating astronomical phenomena. While you're here, check out other exciting videos about space exploration and discoveries.